J rating. Untitled. Say it here.
Hello, you are welcome to our Good Morning Math class. My name is Philip Diseye, and today I'm going to take you on geometric progression. What is geometric progression? Geometric progression is a sequence that the ratio of a term to the previous term is constant. Now, the constant ratio is also called the common ratio and is denoted by the letter arrow. Now, the first term of a geometric progression is given as A. The second term of the geometric progression is given as A arrow. The third term of the geometric progression is given as A arrow square. So the fourth will be A arrow cube. The fifth will be A arrow raised to the power of 4. Just like that, you keep adding 1 to the next term. Now we also have what is called the nth term. The nth term of the geometric progression is given as A arrow raised to the power of n minus 1. In geometric progression, there are two types of sequence. We have the increasing sequence and the decreasing sequence. An example of the increasing geometric sequence is 2, 4, 8, 16 is increasing. Now, in geometric progression, we are not looking for the difference between each term. We are looking for the common ratio between the term. And by the definition, we say geometric progression is a sequence that a term to the previous term is constant. A term to the previous term is constant. A term to the previous term is constant. So you use the one ahead to find the previous term, to find the ratio. So for instance, for us to find the common ratio in this sequence, we can use this and this, or this and this. So we have, for instance, this is 8 divided by 4. That will give you 2. So 2 is the common ratio for each of them. 16 divided by this, by 8, is still the same thing as 2. 4 divided by 2 is still the same thing as 2. So the common ratio for each of them is 2. This is the increasing geometric progression. Then we also have the decreasing geometric progression. So all you need to do, for instance, we can just tilt this to this side. If we tilt it, we have 16, 8, 4, and 2. Now the two sequences don't have the same common ratio. Like, we are still using the same way to get the common ratio. This term divided by this previous one gives you the ratio. This term divided by the previous term gives you the ratio. This term divided by the previous one gives you the ratio. So, for instance, let's get the common ratio. This divided by this, it will be 2 divided by 4, which is 2 go here is 1. 2 go here is 2. So it's half. The common ratio is half. The same thing applies here. 4 divided by 8. 4 go here is 1 time. 4 go here is 2 times. It's the same thing as half. The same thing applies here. This term divided by this term. So we have 8 divided by 16. 8 go here is 1. 8 go here is 2. The same half. So they all have the same common ratio as half. That is what we mean geometric progression. There must be an existence of common ratio in each of the terms in the sequence. Now, let us go to our first example for today. Example 1. The second term of a GP is 3, and the common ratio is 2. Find A, the fifth term, B, the eighth term, and C, the 10th term. So for us to find the 5th term, 8th term, and the 10th term, we have the second term given as 3, and we know the common ratio to be 2. So with these values available, we can find the 5th, 8th, and the 10th term. Now for us to do that, the second term is given as, by the general formula, the second term is given as A arrow, and the second term is equals to what? 3. Now, A is the first term. The common ratio is already known as 2. So we substitute here, we have A2 is equals to 3. For us to find the first term A, we divide both sides by 2. So A is equals to 3 over 2. Now that we have known the first term and the common ratio, we can now find any of the term in the sequence. So let's now look for the 5th term in the sequence. By the general formula, the 5th term is given as A arrow raised to the power of 4. Now we have known the first term as what? 3 over 2. The common ratio is 2 raised to the what? Power 4. So 2 raised to the power 4 simply means 2 times 2 times 2 times 2, which is equals to 16. So we have 3 over 2 times 16. So 3 times 16 is equals to 48. 48 divided by 2 is equals to 24. So the fifth term is equals to 24. Now let's look for the eighth term. The eighth term, by the general formula, is given as a arrow raised to the power of 7. Now, the first term, a, is giving us 3 over 2. The common ratio is 2 raised to the power of 7. 2 raised to the power of 7 simply means 2 times 2 times 2 times 2 times 2 times 2 times 2, which will give us 128. So it's equals to 3 times 128 divided by 2. 3 times 128 is equals to 384. 384 divided by 2 is equals to 192. So the eighth term is 192. Now let's find the 10th term in the sequence. The 10th term, by the general formula, the 10th term is equals to a arrow raised to the power of 9. Now, the first term a is already known to be 3 over 2. The common ratio is 2. 2 raised to the power of 9 simply means 2 times 2 times 9. So that will give us 512. So we have 3 times 512 divided by 2, which is equals to 1536 divided by 2. This will give us 768 as the answer. Now that we have found the 5th, 8th, and the 10th term, we can find any other term in the sequence using the same method. Then we also recall that we have what is called the nth term. The nth term can also be used to find any of the term in the sequence. Let's, for instance, find the 8th term using the nth term formula. The nth term is given as a arrow raised to the power of n minus 1. Now, for you to solve the nth term, we all know that a is the first term. So it is the same thing as a1. Arrow raised to the power of n minus 1. Here, n stands for any of the term in the sequence. Therefore, nth term is the same thing as an, where the n stands for any term of the sequence. Since n stands for any of the term in the sequence, we have the first term as a1, then the second term will be a2, the third term will be a3, the fourth term will be a4, just like that. So since we are looking for the eighth term and we have known the first term and the common ratio, the nth term will now be 3 over 2, which is the first term, multiplied by the common ratio 2, raised to the power of n minus 1. So this is the nth term formula. With this nth term formula, we can now find any of the term in the sequence. So let's find the 8th term now. So the 8th term will be a8, which is 3 over 2 multiplied by 2 raised to the power of 8 minus 1. That will now give us 3 over 2 multiplied by 2, 8 minus 1 will give us 7. And 2 raised to the power of 7, as we have known, is 384. 384 divided by 2 is equals to 192, just as we have calculated before now. So using the nth formula, we can now find any of the term in the sequence. We can look for the 6th term, the 7th term, the 12th term, the 100th term, whatever term you are looking for in this sequence. Using this nth term formula, we'll be able to find it. That is the importance of the nth term formula. This formula is basically for this example. So every other nth term formula, you need to find the first term and the common ratio to get the formula. Thank you for watching.